Let's start over here. Over here to the side are a couple of mini circuits, high power amplifiers, laboratory type amplifiers, but we'll get to those in another video. Up here is my old EIP 548 frequency counter. It goes up to 26.5 gigahertz. I don't really need it in that frequency range because I have a Tektronix microwave frequency counter for that. But I do have the mixers for this EIP 548, so I can go up to 110 gigahertz. And in recent experiments, I needed it for 47 gigahertz amateur radio stuff, so I just keep it on the bench. And down here, this old HP signal generator. I love keeping it on the bench because it is perfect for using, or for if you need low-level signals. It goes up to about 1 gigahertz, and what I like is that the output level goes down very much. You see this here, negative 139 dBm. That's extremely low. And I like using it for receiver sensitivity testing and that sort of stuff. Then next over here we have the Teledyne LaCroix wave station. It's the 160 megahertz model. I use that for all kinds of stuff, just general purpose signal generation. Down here I have an old spectrum analyzer with tracking generator. Now I do have a more modern vector network analyzer, but I like this box. And I keep it on the bench for a simple reason. I use this for my general purpose testing, and I keep it on the bench because when I do general purpose stuff, I'm often quick, hectic, and when you're quick and hectic, you do mistakes and things break. And I rather break this than breaking my VNA. And if I really do need the VNA, I'll get it out and use it. Okay, further over here, let's start on the bottom layer. You see there's the Tektronix MCA 3027 microwave frequency counter. It goes up all the way to 27 gigahertz. Actually, does it say 30 gigahertz? I'm not sure. I think it's 27 gigahertz, but it does actually, there we go, 27 gigahertz. But it does actually work up to 30 gigahertz and a little bit higher. If you look on my Twitter feed, you'll see a picture of me measuring 31 gigahertz with it. Then down here, the Keithley state-of-the-art DMM 7510. It's the brand new 7.5 digit multimeter. Like I said, this thing is absolutely state-of-the-art and one of the best ones out there. And right below its companion is a Keithley, I think it's 2280 is the model number. It's the 30 volt 6 amp DC power supply. Really nice unit. We're definitely going to have a look at that sometime soon. And let's go this way. Right next to it, the Tektronix AFG 3000 series 100 megahertz dual channel signal generator. What I love about this box is that it actually allows me to modulate both channels independently with an external signal. Many other signal generators, such as the LaCroix wave station and Rigel gear, they have one external modulation input, and when you have two channels, you sometimes wish to independently modulate them, and you can't do that with those instruments. Right next to it, we have the MDO 4000B with the 6 gigahertz spectrum analyzer. A really nice instrument. I'm sure you've seen it around. Thanks to Tektronix actually supplying me with very decent probes, like a 1 gigahertz differential probe and that sort of stuff. It's actually extremely useful for all kinds of stuff, and in the future we're going to look at some high-speed digital signaling and that sort of stuff. Okay, and right next to it is the Tektronix LaCroix HDO 4000. You've seen it a lot. I think that's the oldest oscilloscope here in my lab, and most of my viewers are well used to seeing that one. Then let's back up a little bit, and up here we have a cheap Chinese power supply. Just for general purpose stuff, and on top of that there's a 25,000 volt power supply from United Nuclear, and right next to it is a portable 10 megahertz reference. Next to that is a 3 gigahertz frequency counter and a Rigel signal generator. I would love to put the LaCroix wave station right on top or below the Rigel SIG-Gen, but unfortunately the LaCroix wave station is too long for my shelf. Now you notice one thing. There's a coax connected to the 10 megahertz reference input. And this is something very interesting to notice in this lab. Absolutely every single instrument in this lab that does have a 10 megahertz reference input is connected to a Jackson Labs frequency standard. That's a GPS locked, double ovenized reference timing source. And I'm using a TV distribution amplifier down here that's been a little bit modified to do this sort of stuff. If you want to see instructions on that, swing by my text blog. I've written an article on that. And while we're here, down here I have this 700 to 2700 megahertz 100 watt HPA amplifier from Mini Circuits. This thing can handle an open or a short, and of course any impedance in between at the full 100 watts. It's just insane. We're going to use it in some videos soon where we're going to test some aviation related stuff. Alright, let's continue up here. There's a Mini Circuits switch matrix that can be controlled over USB, and below that is a USB controlled synthesizer. And we're going to use both of those for some automatic test setups soon that you'll see here on the blog. There is a DME, distance measurement equipment for aircraft. You basically dial in a frequency of a DME and it'll display either your distance, time to the station, or your speed on that display next to it. Now this is just laying there because I've been working on that. It was broken, I fixed it, and we're gonna use it on the blog to explain some aircraft stuff, but obviously this is not a permanent installation. Right next to it you see 2 multimeters, you can never have enough of those, and a TI-84 calculator. Next over, a screen. I use this for all kinds of different stuff. I use this sometimes for my camera output when things are getting tight here and I need to see what I'm doing. I use the screen. Sometimes I connect it to my oscilloscope outputs, such as I'm now doing it. Especially with the LaCroix scope, and you can see this here, I have a big problem. It has so much glare, and I've tried polarizer filters and that sort of stuff, and it's just a pain in the rear. So what I originally wanted to do is film off the screen, but luckily I came to a little bit of money and just bought a Blackmagic Intensity Shuttle 2, which is a HDMI and HDSDI recorder. So I'll just record directly off the scope screens and either include that in the video or actually mask out the oscilloscope screen and mask the screen capture directly back in it. Alright, next over here we have a hot air rework station, very important. I used to have that one in the garage on the workbench. Same goes for this PCB rotary saw and the drill over there, but I brought it inside simply since all my soldering, all my PCB development, all that good stuff happens over here, so I thought I'll bring it inside. Various bins and cabinet for all kinds of stuff, and that's just the stuff that I need in close range. You've seen other videos with all kinds of boxes laying around, so they're not all out here. So here's another pan shot of the whole lab, and here's my little hanger with the cable and cables, and there's tons of cables in those drawers too.